Well, I guess we're live. Can you hear me? Can you guys hear me? Hello. Yes. Yes, we are live, guys. Hello, all. Welcome to the channel. Welcome to the next episode. Before we start off, I want you all to keep your distance. Okay, stay away from other people. Stay at home. Stay safe. Look at this. It's a wonderful diagram here. Wonderful moving GIF here. So I want all of you guys to stay at home. Keep your distance from everyone else. I know these are difficult times, but then this is the best thing to do for now till you get a vaccine or something like that. Okay. So yes. So while you're staying at home, crack IIT-JEE with India's largest platform, which is Unacademy. Undoubtedly, get the Plus subscription and access unlimited live and recorded courses from across India's best educators. So get the subscription right away and install this app right now. Okay, install the app, Unacademy Learning app. This is how it looks. It's pretty cool. You have the daily quiz show happening today. The quiz show, which happens every day, is happening today. The daily quiz show. You stay tuned into that at 10:30 p.m. All right. Don't forget to reach that quiz. Install the app right away and get to the quiz show. You can search by name N Srikant and you'll find me there. So yes, that is me. I am N Srikant, guys. I did my BTech from IIT Kharagpur with an AIR of 385. I've been guiding young minds like you guys for the last 4+ years. Yes, I'd like to call myself a guide because I'd help you with your flow rather than telling you something else to do. You guys call me human calculator. Well, we'll find out why. I'm a Sunrisers fan and DC is equally marvelous, if not better. I'm a DC fan. Joker का big fan हूँ मैं. ठीक है. All right. So this is the program I've launched for you guys. It's called Ad Astra. It is aim for the stars and crack IIT-JEE. So Ad Astra means aiming for the stars and aim for the stars and on the go just crack IIT-JEE. It's not like you only prepare for IIT and then get it. Aim for everything. Yes. Hello. Hello, Giribav Garu. Hello, good evening. Say hi, Sim24. Welcome. So today we have very few things to discuss. It's a very simple session. We'll have some problems on potential, which we already discussed a lot, and then we are discussing a new topic called electrostatic pressure, which is the end of potential. All right. So we will do a lot of problems today. So those who have got the answers, please make sure to answer it on the section below. Like just put it in the live chat. All right, I'll see it and I'll tell you if it is right or wrong. So this is one of the single option correct answers. Which one is for a spherical symmetric charge distribution? Again, when a charge is distributed spherically, which Gaussian surface do you use? For spherically symmetric charge distribution, we use a spherical Gaussian surface. Right. For spherical and point charges, we use spherical Gaussian surface. That is the first thing we have to understand. Yes, electric field at distance r from the center is given by E is equal to k r power 7. Bapare. This k r power 7 r cap, which means it is going outside radially from the r cap, we can understand, and it is k r power 7. Wow, it's a huge one here. What will be the volume charge density at a distance r from the center of the sphere? So he is asking us to find volume charge density. We know field is k r power 7 r cap. So at a distance r, what will the field generally be? If we take a distance r, we know that q inside by epsilon naught will be equal to the flux. This is the first thing we know about at a distance r, and we also know the flux will be equal to integration of E dot ds or dA. So at a distance r, we can directly equate these both. From these both, we will directly get integration of E dot dA will be equal to q inside by epsilon naught. Okay, yeah, this is one thing we understood. And what do we know about q inside? Q inside can be defined as charge density into volume, right? So this is what we'll apply all these and we'll get the answer. And since we know field is directly going outside, this whole thing, the dot product will directly become into E into area, because the both are at the same angle. If you observe spherical surface, the surface area is always outside and the field is also given from the question to be going outside. So both of them are along the same direction, field and the radius vector and the area vector. So directly E into A will be equal to density into volume by epsilon naught. बस इसको calculate कर दो. Density will be E into A into epsilon naught by volume. हो गया? Simple question. This is all straightforward, simple calculations. Yes, good evening guys. Yes. तो field कितना है? K into R power 7 into area is 4 pi R square into epsilon naught by volume is 4 by 3 pi R cube. ठीक है, the pi is gone, 4 is gone, R square becomes R here, this R makes it power 6, so directly we will get the answer to be 3k R power 6 epsilon naught or 3k epsilon naught into R power 6. Getting it? Just give me a moment. Density into volume, the charge density at a distance r from the center of the sphere. So it is proportional to the density is proportional to R power 6. Only option which matches that is option A, which is the correct answer. Alright. So this is how we get it. Q into A. Alright. I think there is a small problem with this. This should supposed to be 3. So that is the correct answer, guys. The answer is 3k R power 6 into epsilon naught. Yes, that is the first question. Now for the next one, the 4 charges are placed at the circumference of a dial clock as shown in the figure. This is a general recap of the topic. Okay, all these questions will be general recap of the topic which happened till now, which is electrostats. The 4 charges are placed at the circumference of a dial clock as shown in the figure. It's a dial clock with 3, 6, 9 and 12 given here. If the clock has only R hand, then the resultant force on the charge Q0 placed at the center points the direction which shows the time as. So this is a very interesting question, guys. I will on the timer for you guys here. Okay, so this is the question. It is given that the clock has only R hands. So the R hand is pointing at which particular time? Alright, so and the R hand is pointing at the direction of the charge. So what is the direction of the field due to all these charges? I'm going to give you 1 minute. It's a very fairly straightforward question. Yes, so you know the field due to a positive charge will always be radially outward and field due to a negative charge will be towards itself. And one more thing I can explain here is that all the 4 charges are at the same distance from the center charge Q0. Getting it? From the center charge Q0, all the 4 charges are at equal distance, which means the magnitude will be same. Hello Sairam Garu, hello Amma. Good evening. Okay. So what can the answer be? Logically सोच से ही answer हो जाएगा. This is a very theoretical question. It's not a formula based or anything. It's just logical approach. So let's see how many of you can get this right. Yes, option A and option D. Well, ये गलत जवाब है. Ta-da-da-dam. Let's see why. Let me explain. Okay, chill. The field due to this plus Q charge will be in this particular direction, right? It will be downwards. And the field due to this will be in this particular direction. So field due to 12 and field due to 3 are along these both directions. Now what about field due to 9. The field due to 9 is also along this direction, and field due to minus q 6 also is along this direction. The result of both of them will be along this particular direction. This will be the resultant direction. What time does that show? Yes, exactly. The answer then is B. Good one, Sim24. Nice try, Giribabu. Okay, so this is the next question. Now for this one, this is a little tricky. Okay, this is a very good use of Gauss law. I want you guys to understand how to apply Gauss law using this is a very wonderful question. Okay, the diagram shows a uniformly charged hemisphere of radius r. It has charge density rho. This has a charge density of rho. Okay, if the electric field at a point 2r above its center is E, at this point the field is E, then what is the field at a distance 2r below its center? At this point, what will the field be? That field is given as E. So this is the question, guys. I will give you a couple of minutes to solve this. Just take your time, think about it. It's a good analytical question. Come on, Sim24, you can do it. Sim24 and Ramesh. So this question, you have to use the concept of symmetry in a little different way. Okay, it is saying from the center, the upper particle and the upper point and the lower point are at equal distances, right? The point which is on top, A and B, are at equal distance from the center of the circle. So from this, what from the center of the half sphere. So what can be symmetric in a half sphere? It is a full sphere, right? So you can make it into a full sphere and then solve the equation accordingly. So that's a very interesting approach. This question is a lot of analysis. So yes. These kind of questions are very analytical. Like you have to understand the broader perspective. This is not more formula application. This particular question, like the previous one, is more analysis based. All right. So just you have to understand how to Sim24. I think that is not the answer. I don't think that is the correct answer. Let's see. Okay. Even I don't know the answer, frankly speaking. But I'm guessing it is the wrong answer. So the time is up. Can you hear this? All right. If it starts again, it will be a huge sound, so I'm cancelling it. So now this I will write in a little different way. I will make it into a complete sphere. Okay. I will make it into a complete sphere having charge density sigma plus a half sphere having charge density minus sigma. Yes, this is what you did, right? Okay. So the field due to this plus the field due to this will be the right answer. Getting it? So now at point A and at point B, what will the field be? So here you can take a Gaussian surface, and if you observe carefully here, the field at B in this particular case will be same as the field at A here. The field at B in this particular case will be same as field at A because it is facing in the same direction and so on. So you can say field at B due to this will be equal to field at A, which is equal to E. Understanding it? So the field at this point due to this whole negative charge is equal to E, and due to this full charge we have to find out, and sum of both of them is the answer. Are you getting the concept here? The full sphere, the field at B due to the full sphere plus field at B due to this half sphere will be the answer, will be the total field due to this. Getting it? So now due to full sphere at a distance 2r we have to find out. We can take a Gaussian surface and solve this. So from this directly we'll get the answer to be what is the field at this surface due to be? Field due to the first part will be Q inside by epsilon naught into area. Just substitute the values. Q inside will be rho into 4 by 3 pi r cube by epsilon naught into area is 4 pi into 2r whole square. If you observe, it's 2r whole square. Getting it? This is the main function there. 4 and 4 and this whole thing is getting cancelled. R cube and R cube will also, R cube and R square will get cancelled. Right? R cube and R square will get cancelled with an R on top. So from this remaining you will get rho into R by 12 epsilon naught is what you're getting. So the field due to part 1, E1 will be equal to rho R by 12 epsilon naught and E2 will be equal to E. In the opposite direction, if you observe, it's just in the opposite direction. Getting it? This is downwards. If you observe, the direction of field is downwards here and the direction of field is upward here. So E total can be written as what? E1 vector plus E2 vector. If the sum of those both is the resultant, right? So is the audio clear? Sim24, is the audio clear? So E1 plus E2 is the total value. Now what is the value of E1? It is rho R by 12 epsilon naught in the downward direction. This is why I use logic, because you will not get confused with addition or subtraction if you use the logic. And it is E in the upward direction. The result of both of them will be rho R by 12 epsilon naught minus E. Clear? Understood? It is as simple as this, guys. So the option is B. To be or not to be. Okay, now this is another interesting question. Most of the questions are multiple concept based. I wanted to involve a lot of multiple concepts so that. Oh yeah, it's audible. Oh, nice. So yeah, I'm going to put that sound everywhere because I want you guys to listen to it and get attentive. Okay, a metallic rod of length L rotates at an angular velocity omega about an axis passing through one end and perpendicular to the rod. So this is how generally a rod will look. It is passing perpendicular to the rod and it is rotating about this axis like this. It is having a length L and it's rotating with omega. All right. Okay. So a mass of electron is m, and its charge is e. If the mass of electron is m and its charge is e, then the magnitude of potential difference between the two ends is. This is a very nice question, guys. So now one thing we know. What do we know about it? The electrons will have an external force in the outwards directions. Electrons which have mass m experience outward force, right? Experience outward force due to circular motion. Now this particular circular motion will cause the field. So you can also simply say the net force due to the circular motion will be equal to the field will be equal to the electric field produced. You're able to do it easily. Oh, hello Anjali, welcome. And hello Ramesh Sisla, thank you. This question is a little more complicated than that. I will give you time right now. I will give you a couple of minutes. A couple of minutes for this. Yes, your time starts now. It's already started, so you guys have to do it. Come on, you have to do this question, Ramesh. Let's see. So here there is a force inward due to there's a force inward. There should be a force inward because of which the electrons will stay at the throughout the body, right? The magnitude of potential difference between its two ends will be equal to the net force acting on the particle which is going through the entire body. Okay. So here you can simply say the force due to field on the charge will be equal to the net force on the electron. The masses of electrons. This question involves a little integration also, you see. So whenever you see these kind of questions, I'll give you on logic. Okay, you have to understand the logic behind how to solve this kind of this basic question. This is not a little basic; it's a little more complicated than basic. But let me explain. There's a very simple method to it. Okay, time is up, guys. Yes, very good, Ramesh. You got the correct logic here. The answer is A. How did you get it? Let me explain. Okay. So at a distance x everywhere, you know the acceleration due to circular motion is always given by omega square into r, right? Where r is the radius. So what happens in these kind of questions is there is electrons everywhere here. There are electrons everywhere here. So everywhere the electron is feeling a little potential, a little acceleration inward, which is provided by the field. So across the entire body, the field is moving in this direction. Yes, it is exactly correct, Anjali. That's correct answer. The answer is A. So let me explain how. Acceleration centripetal across every point here is varying, and everywhere the field is also varying. So you can say the field will be equal to the force. Is this force? This acceleration is provided by the field. This is provided by who is providing circular motion here? The field is only provided by the field. So you can simply say EE will be equal to m omega square into r. What is r here? Radius will be anything. If across the entire body, radius will be there. So you can directly get E will be equal to m omega square r by. So now let's solve the second half of the question, where r is the distance from the center. If you take a small dr element, there the field is given by m omega square r by E. So what is potential difference? Now we got the point. It is integration minus integration of E dot dr, right? So now this is exactly what we will do. Minus m omega square by E into r dr. Integration of this. What is the range of the length from 0 to L? The entire r can range from 0 to L. So substitute the values here. We are getting. Let me finish here. You'll get the answer is m omega square by E into r square by 2 from 0 to L, which is m omega square L square by 2. The minus sign indicates that the potential is higher here and lower here. Understood? So minus indicates that, but overall the magnitude, okay, we have E also here. Overall the magnitude, if you observe, the magnitude is given by, this is what is asked in the question, the magnitude is given by m omega square L square by 2E. Got it? Delta V is equal to E delta R. Yes, exactly, EDR. Good one, Ramesh. D, you can write D, no, instead of writing the delta and all. Okay, this is one very exciting concept I told in class in one of the previous videos. If you have seen my video, you will get this answer within 1 minute. It's a very nice trick. Okay, I'm going to give 1 minute for this question. Otherwise, it becomes very complicated. So the question starts now. So the question says finite charge rod, electric field at a point P. The point P is here. The point P is given there. Makes an angle theta with the dotted line. Then angle theta is. So we discussed this a very interesting concept, guys. So if you remember that, it's a very straightforward question. Otherwise, stay tuned to the video. to arc. This is so we are back again. Can you guys hear me? So we are back again. Okay, so this question, sorry for the delay, guys. There's been a little technical issue which happened right now. So now we know this line will behave like an arc. So the entire line will behave like an arc. So if you now find the angle, the total angle of the arc, if you see, is from 32 degrees to 88 degrees. To 88 degrees. So the total will be 120 degrees and the resultant direction is along the angle bisector. So from this we can get the angle will be at 60 degrees from the top and 60 degrees from the bottom. Now if you see the horizontal line, the upper angle is 32 degrees and the resultant is at 60 degrees, right? Which makes this angle 28 degrees. Got it? Yes. That's a simple solution for this. It's a pretty simple one. Line is equal to arc. This is the trick we generally use here. Alright? Okay. Now for the next question. The electric potential in a region is given by the relation V is equal to 4 plus 5x square. Okay, this is the electric potential. Okay, this is a multiple choice correct, multiple option correct by the way. So you have to be a little more careful here. Is multiple option correct? So if a dipole is placed at position minus 1 comma 0 with dipole moment P pointing along the positive x direction. So we know one thing, the field is 4 plus 5x square, right? So from this we can say the electric field will be minus dou v by dou x I cap. Remember this, minus dou v by dou y j cap minus dou v by dou z k cap. This is the general formula we use to find out electric field in reverse from potential. So directly I'll get the field to be equal to minus 10x I cap. This is the first thing we got. Where the dipole is placed at minus 1 comma 0, the field at minus 1 comma 0 is equal to simply the value of this. It is simply minus 10 into minus 1 I cap, which is 10 I cap. Got it? And the position of the particle, now if you observe, now if you see, the dipole is placed along the positive y direction is given, right? So the dipole will be placed here. Let's make the dipole color green. The dipole positive charge is here and negative charge is here. It's placed vertically like this, and the field is given in this direction, which means what is the torque? This negative charge will experience a force here and the positive charge will experience a force here. And one thing we know, they both are equal and opposite, right? Because the dipole width is almost small, we can say the net force on a dipole will always be equal to 0 no matter what. At very small, very good answer, Ramesh, good one. And the net torque on the dipole is in the clockwise direction. This will move this way, this will move this way, as a result of which it will start moving in clockwise direction. So the answer is AC. Okay. Now this good answer, guys. The same way I did it. Yes, very good, Ramesh. This is the main trick you have to remember. Yes, very nice. Now for a comprehension question, guys. It's another comprehensive question. This is a multi-concept one again. It is a combination of rotation and electric field and electric potential and everything we know till now. Okay. A thin homogeneous rod of mass m and length l is free to rotate in a vertical plane about a horizontal axis pivoted at one end of the rod, which is pivoted at this point. Okay, the a small ball of mass m and charge q is attached at the opposite end of this rod. The whole system is positioned in a constant horizontal electric field of E is equal to mg by 2q. The rod is released from rest as shown in the figure. The angular acceleration of the rod at the instant of releasing the rod. Okay, this one you can answer. I'm going to give you 1 minute to answer this. The time starts now. Yes, so this question, the angular acceleration of the rod at the instant of releasing of the rod. The moment it is just left to move freely, there will be a lot of forces which are acting on it, and the result of all the forces will give you torque. Net torque will be equal, and you have to find out torque about center of mass. Okay, I will give you 1 more minute. 2 minutes, yes. If that is what you need, we'll have it. But solve this question, guys. It's a very good one. It's a good question to help you understand all concepts at once in one go. Torque, writing equations of torque, and writing equations of forces, and also electric field. Okay. C mostly, very good, Ramesh. Great job. I think that is the correct answer. Nice, man. You develop the intuition to solve the answer partially and get the answer. Is it, or you solve the whole thing? Intuition will work. I'm telling you, that is what I'm telling you, guys. I keep telling this every time. Intuition will work 90% of the times. Only that you have to get that confidence in your intuition. You have to trust your intuition. Before we stop. Good, Ramesh. Very good. Oh, that's even better. Okay, so now we'll just see the forces, because this question is multiple concept. It is a combination of rotation and electric field also. So the charge, it plays a mass is placed here, so mg will be downwards here, and this entire rod will also have a mass mg downwards. Not only this has a charge q, so the net force in this particular direction will be equal to mg by 2. mg by 2q into q, right? So a resultant force in this particular direction, this is the force due to electric field. These both are forces due to gravity. The rod is released from, as shown, from rest. Okay, so now what is the total torque? Torque total will be equal to, one thing you have to understand, this force due to the electric field will not produce torque because the line of action is passing through the hinge point. If when the line of action passes through the hinge point, the torque will be 0. Getting it? So if you, whenever, that is why when you push a door along the direction of the door, like this is a door hinged like this, if you push the door like this or pull it back, it won't rotate because the hinge is along the line of action. So this will not produce torque, but these both will produce torque. The perpendicular distance is L by 2 here and L here. The torque total will be mg L by 2 plus mg L. 3 mg L by 2 is the total torque. And what is the total moment of inertia? It will be ml square by 3 plus ml square. The whole rod ka ml square by 3, and for the point object it's ml square, which comes out to be 4 ml square by 3. So now what is alpha? Torque by torque is I alpha, so I alpha will be torque by I, which is 3 mgl by 2 into 4 ml square by 3. Cancel out the mass and cancel out the L, you're getting the answer to be 9g by 8L, which is option C. Great job, Ramesh. Very good. Keep doing the good work. Next question is, what is the speed of the ball when the rod becomes vertical? So what is the meaning of vertical? Not upward. It will become vertical in the downward direction. It will come like this. Okay, when the rod becomes like this, what is the speed of the ball? So this is the next question. I'm going to give another couple of minutes. Starts now. Here we have to use the concept of conservation of energy. Okay. We know electric field is conservative, so we can directly use the concept of conservation of energy. Okay. Yes, 2 minutes is given, Ramesh. I have given 2 minutes. You have 44 seconds to go. So this one, guys, this is a concept of conservation of energy. Okay, you have to use conservation of energy here. So energy, which means the work, there is a work, certain work done by electric field, there is a certain work done by gravity. The sum of all of them together will be equal to the kinetic energy of the system given here. Clear? The total by both of them, the total work done by field plus work done by gravity. Yes, time is up. Yes, very good, Ramesh. Great job, man. This is excellent. Great job, Ramesh. I'm proud of you. Good one. So that is how you just apply all of them together. Exactly. Work energy theorem. Work done by all forces is equal to change in kinetic energy. So in this particular case, I can directly use rotational kinetic energy. I know the moment of inertia is 4 by 3 ml square. So I'll directly use half into I into omega square instead of taking individually of both of them, will be equal to work done by gravity plus work done by electric field. Got it? Work done by all forces is equal to change in kinetic energy. Initially it is at rest. So finally we can find out this. So just use it, half into 4 by 3 ml square into omega square will be equal to what is the work done by gravity now. Now this part, the center of mass of the rod is falling down by L by 2 and the whole ball is coming down by L, right? So the total change in total work done by gravity will be one mgh and the other mgh2. So work done by gravity will be mgh by 2 plus mgh, right? This is 3 mgh by 2. And what about field? The field is acting in this particular direction and the force we already discovered is equal to mg by 2. And the particle which is here has moved back along this direction till this vertical, no? So the particle moved L distance here. So the work done by electric field will be minus mg h by 2 or L by 2 basically. L everywhere. So total work done by all of them together will be how much? 3 mgl by 2 minus mgl by 2. Given we will get the total work done is mgl. So just substitute the whole thing here. I will get 2 by 3 m L square omega square is equal to mgl. M and m are getting cancelled, so we'll get omega is equal to root 3gl by 2, 3g by 2l. And what is velocity? Speed of the particle is m into l, is omega into l, right? This particle will have, this is rotating with omega, means the distance separation is l, hence the velocity will be equal to omega into l. Velocity will be equal to root 3gl by. Great answer, Ramesh. Keep the good work going. Now, what is the acceleration of the small ball at the instant of releasing of the rod? This question is just an extension of the first question. If you remember the first question, this is the straight answer. Okay, I won't be giving time for this because I know you already, all you guys already know it. We found out the acceleration was equal to 9g by 8l, right? Alpha. So at this instant, if this is having an alpha, this is at a distance L from this. So what will the acceleration of this be? Alpha into r. We'll use the same logic here. So the acceleration of the particle will be 9g by 8l into L. 9g by 8. Yes, guys, if you observe one thing, one very interesting observation here, which I would like to share it with you guys, is the acceleration of the body. If it was normally falling, if this whole setup was normally falling, like these both are not connected, the mass would have fallen down with an acceleration of g. But with the rod being there, it is falling down with more acceleration. Getting it? Since the rod is there, it is falling down with more acceleration, which means if you have a block like this, the normal force on this block is downward, on the small particle is downward. It is giving extra force in the downward direction. Understanding it? Which also implies that if this particle was not there, this rod would have fallen faster than g. Are you able to understand the subtle things? The acceleration of the cornermost point is given as 9g by 8, right? That is what we derived. The acceleration of this is 9g by 8. If there was no rod there, it would have fallen with g. So contrary to the belief that freely falling body pe upar, if you put something on hinge is also there, which means it will fall slowly, that is not the case. This rod will move faster. If this body was not there, the rod will move faster than the mass itself. Hence it is coming faster and pushing it down. Are you able to understand this? So this is one interesting observation. The normal force, if you put a block like this and you put a block on top, on the rod, this block, this will go faster than this. This will go faster than freely falling body. Faster than freely falling body. This is one inference you can imagine. Alright. Okay. Now for the next question, it's an integer type question. A simple pendulum is suspended in a lift which is going up with an acceleration of 5. An electric field of magnitude 5 Newton per coulomb is directed vertically upward is also present in the lift. The charge of the bob is 1 microcoulomb and the mass is 1 milligram. Okay. Taking g is equal to pi square, the length of the simple pendulum is 1 meter. Find the time period of the simple pendulum. Okay. So how do we solve this? Okay, I'll explain this question. It's a little lengthy, so I'm going to solve this question for you guys. Ramesh, if you get the answer, type it before. Else, I will start explaining slowly. One thing you have to understand, what is the time period? Time period. There's a wonderful trick I'm going to tell you about time period, guys, of a pendulum. Time period of pendulum. This is a wonderful trick which will work every time for a pendulum. Okay. It is generally when there is when there is extra force and all on a pendulum, it will start accelerating, right? So my answer for time period of pendulum is when you cut the pendulum, the acceleration of the block, whatever the acceleration of the block is there, of the pendulum bob, not block. When you cut the pendulum string, whatever the acceleration of the bob is there, time period will be equal to 2 pi root L by acceleration of the bob. So this is a very simple method of solving it, guys. This way you just cut the pendulum string and you can just see what all forces are acting, add all of them, you will get the answer. Getting it? This is a wonderful trick. You just cut the string, and this trick I've never seen everywhere. This is one authentic trick which I give to you guys. Cut the string, find the acceleration, you get the time period. Understood? Pretty cool, right? So now we'll just solve for the bob. What are all the forces which are observed in the pendulum? It's in the lift, right? So there will be one acceleration m into g here and one pseudo force m into a here. Getting it? and there is an extra force due to QE here. Getting it? So this is the trick, guys. Understood? Yes. So now let's solve the answer now. Let's just put it. There's one force mg downwards, and there is one more ma downwards, and g and QE upwards. Right? We'll just quantify all the values. So that is g m into g downwards. It's given as g is pi square. So we'll take pi square into m downwards plus m into 5, which is the pseudo force downward direction, and the upward direction is q into e. Q into 5. Just substitute all the values. We'll get the answer. Mass is given as 1 milligram, which means it is 10 power minus 3 into pi square plus 5 into 10 to the power minus 3 and minus 10 power minus 6 into 5. This is 1 millicoulomb, I guess. This is 1 millicoulomb. So we will have to put 10 power minus 3 here. So you add the whole thing, these both are getting cancelled. And if you observe the time, the total force is 10 power minus 3 into pi square. As a result of which, the acceleration will be pi square only. Acceleration is net force by mass, right? Acceleration is 10 power minus 3 into pi square by 10 power minus 3, which is equal to pi square. So what is the time period? 2 pi root length, which is 1 meter, by acceleration, which is pi square. So you substitute the whole thing, you get the answer to be 2 seconds. Understood, guys? So this is how we solve it. Yes, thank you. Good one, Ramesh. This is also another easy question. Integer graph type. This is a graph type question. I want you guys to understand this graph type questions. Yes, very good. So find the magnitude of the electric field at a distance 13 meters. When the x is 13 meters, what is the magnitude of electric field? Come on, tell me the answer for this one. It's a very simple question. This is V and this is X. The graph given is Vx graph. I'm going to give you 1 minute to solve this, not more than that, because it's a very straightforward question. Create one. So this is one very analytical method. Okay, you know the formula for field. You know the formula for field is minus dou V by dou X. Remember, we have to use the same logic here. What is the meaning of dou V by dou X? It is partial differentiation. It is partial differentiation. In short, it is just differentiation of dV by dx. No. So from this, you can get one very simple trick, that the slope of the Vx graph will only give you electric field. Now tell me, what can the answer be? Yes, exactly. Good one, Sim24. You are back. Time's up, guys. So slope at this particular point is only the field is minus dV by dx. Basically, it's minus dou V by dou x. So it is nothing but negative of slope. Simple. So यहाँ पे slope कितना है? It is delta y by delta x, right? Slope. So delta y by delta x. So slope is 22.5. Hey, delta y is 10 minus 30 by delta x is 16 minus 12, which is minus 20 by 4, which is minus 5. So field is plus 5. That's it. 22.5. Where did you get that number, man? Okay, another part I'll ask you, same thing. The field at x is equal to 4 meters will be how much? Another question. Your 1 minute starts now. At x is equal to 4 meters, what will the slope be? In fact, this is not even, it does not even require 1 minute. So do it quickly, guys. I want to see a first answer, fastest answer first, and then we'll go to the next question. Clear, everyone? Sim24, this is one very big issue with lot of guys out there. It is calculation mistakes. So that is one very major part you have to embrace and you have to understand working. The slope here is 30, the change is 30 here and the change here is 4. What is the slope now? Minus 30 by 4, which is equal to minus 7.5. So the field at 4 meters is plus 7.5 Newton per Coulomb. Getting it? Yes, alright. So did you get the concept now? Okay. Clear, guys? Okay. Now, an infinite plane of charge sigma is equal to 2 epsilon naught Coulomb per meter square. The density is that it's an infinite plane of charge 2 epsilon naught Coulomb per meter square. It's tilted at an angle 35 degrees from the vertical as shown. Find the potential difference between VA and VB if the points A and B are 5 meters apart. So this distance is given as 5 meters. So will you solve this question? I know, that is what I mean. That is the main problem if you're getting in flow. The problem with making calculation mistakes is once you get in flow, you make mistakes despite of doing correct and you end up getting wrong answers. So it's a very tricky place where it is like when you're not in flow, you do it very slowly. You take a lot of time, but you don't do calculation mistakes. You don't have time. But when you're flow and you're doing quickly, you end up making calculation mistakes. So it is like a part of both of them, for which I suggest you guys do meditation. I know it is very tough for everyone to say, everyone to follow it, but meditation seriously helps you a lot in this kind of situations. तो यहाँ पे क्या करना है? That distance is given as 5 meters. You have to find the difference between the perpendicular distance. Like इसका distance d1 मान लो, इसका distance d2 मान लो. So the potential difference between VA minus VB will be equal to field into d1 minus d2 magnitude wise. Since he's asking us potential difference, yes, exactly. One thing you have to understand, how is the direction of field? The field is direction is this way, which means the ones closer to this will have higher potential and this will have lower potential, right? So which one is closer, A or B? By logic, we can say VA will be greater than VB. Again, same mistake, Ramesh. Direct formula, na? Yeah, exactly. Okay. So this is tilted at an angle 37 degrees with a vertical, which means this angle will also be 37 degrees by diagram. So how much will this vertical distance separation be? d1 minus d2 is equal to 5 into sine 37, which is equal to 3 meters. Getting it? So and the field due to this, is 2 epsilon naught. The density is 2 epsilon naught. And the field due to this infinite plane charge is sigma by 2 epsilon naught. So substitute the whole thing, 2 epsilon naught into sigma by into 1 by 2 epsilon naught, which is equal to 1. The field is 1 Newton per Coulomb and the separation is 3 meters. So VA minus VB will be plus, not minus. Ramesh, get the difference, it will be plus. Because like the analysis part is better than directly applying formula. Okay. VA minus VB is E into D1 minus D2. You can directly apply this also. You'll get 1 into 5 minus 2, which is equal to 3. That's it. So 3 is the right answer. So we are done with the basic problems. If you really want to have tough problems, we can have one session like that here. Please let me know. We will start the next topic, capacitors, tomorrow, and before that, crack IIT-JEE with India's largest platform, which is Unacademy for sure. Get the Plus subscription and access unlimited live and recorded courses from across India's best educators. So, what will you get with Plus subscription is you will get access to the best of Unacademy. You will get daily live classes where you can chat with educators here. As you see, there is a little lag between the chat and the discussion, and the chat is also not visible directly, so we have to have a special channel for that. But otherwise, in the app you will get direct chat with the educator. You can engage in live discussions with everyone around. You will have a live chat there. You can ask your doubts. You have a question section there, and you will get answers. You will have polls all while the class is going on. All of these while the class is going on. Okay, not only that, it's still left, we have another topic left, Ramesh, so stay tuned. Electrostatic pressure, that's a new topic which we are going to discuss now. Next, we have live tests and quizzes where you can evaluate yourself with regular mock tests. Like I always say, you need to have a test every day. A quiz a day keeps you ready for JEE any day. That's my quote, as Sim24 says, and as I also already said. A quiz a day keeps you ready for JEE any day. You need to have live tests and quizzes, and those are available in lots of numbers at Unacademy. Not only that, you have structured approach where you get the courses all structured and is given in full material. The entire course material is given to you directly, with which you can study at your will. Whenever you feel like you have a free time to study, you can study. It's not like you miss a class, you cannot learn that again. Most of you have this issue that you miss a class and it's very tough for you to understand what is happening in the very next class. That is very important, and that is what you have to maintain. Not only that, you have unlimited access to all teachers from across the country, from best teachers of physics, chemistry and mathematics from entire country. So the cost of this is 38,500 for 1 year. So that is the main thing I would like you to take. You also have it for 6 months, which costs 28k. But generally, for preparation for now, if you want to crack 2021, yes, for 2021, this is the best option. Take the 12-month course because it costs 38,500. It might look big, but let me explain the whole thing. Use my code NSS1, guys, and you will get it for 34,650. It's an extra 10% off. 34,650 is to 2,888 rupees per month, which is coming close to 96 rupees per day. Now, what is the main thing about it? It is nothing but 32 rupees per day for physics, chemistry and maths. You won't even get tuitions for this fees, and you're getting unlimited benefits here. So this is why I'm telling you guys to go for the Plus subscription right away. Not only that, for 2 years, if you're cracking 2022 JEE, you can use this use the 2-year course. Use the code NSS1 there, you will get it for 50,400. Matlab, this is like extra 10%, 6k off, and this comes out to 23 rupees per day. All right, so what are you waiting for? Let's go for it. Not only this is a new iconic subscription which is going to bring you closest to a personal. This is the closest to a classroom program you'll have, and especially for those guys who have little trouble understanding what to study. You are interested in studying, but you don't know which subject to study and when to study those. So a personal coach will be there. He'll be helping you he'll be giving you guidance to align your preparation strategy. Not only that, you'll have test analysis. You'll have in-depth test analysis with your personalized feedback to improve time management and exam approach, along with a study planner. Hello Nithin, how are you? Welcome. You have a study planner here which will help you with with weekly study plans, bi-weekly study plans based on your things, along with all the benefits of Plus. Yes, I remember, man. J2 Nikhil and Nitin. Yes, the cost of this is 50,000 for 56,000 for 1 year. Use the code NSS1 again, get it 50,400. So this will come out to 46 rupees per day for physics, chemistry and maths with a teacher. So it's awesome. Go for it, guys. All right. So today we are discussing about a new topic. Hello, Nikhil. Nitin, come every day, man. We have a class every day at 8 o'clock. I'll be changing the time. Ravi Sailendra, did you remember me? Well, I have trouble remembering names. I can see you, then I can remember you. Okay. So force due to electrostatic pressure is directly normal outwards to the surface. The force on small ds charge. So we are discussing about electrostatic pressure. Now when there is charge on the outer part of a bubble or something, let's take this a bubble which is having an outer charge. There is a charge on the outer surface. So what will happen? This charge will automatically repel each other, right? It is just exactly opposite to surface tension. If you observe, surface tension will try to pull everything inward. and this positive charge will try to increase the radius of the bubble. Getting it? You're able to understand the synonyms there, like bubble, a surface tension will pull it inwards, and the electrostatic pressure will pull it outwards. So this will happen. So when a bubble or any or balloon is provided a positive charge, what will happen to the pressure inside the balloon? The pressure inside the balloon will decrease because the balloon will try to expand automatically. As a result of which, the pressure inside will reduce. Now, how much will it reduce? Well, that is what we'll find out right now. Okay, so on the surface of a charged body on a plate, let's take a small ds element. Take a small ds element like we took here. The field will be exactly vertically outwards. Got it? So how much will the field be? Field is generally given by sigma by 2 epsilon naught, right? We know the field already. And what is the force acting here? The force acting will be charge into field. If you take a ds position, we know the density is sigma. For ds element, the charge will be dq will be sigma into ds. So we know for a ds element, the charge is sigma into ds and the force is q into v. So if you observe how much is the df here, it is nothing but sigma into ds into e, which is also equal to, substitute this here, I am getting something like sigma square by 2 epsilon naught into ds is df. So this is the force. Now what is pressure? Pressure is rate of force per unit area, no? So directly send this to the other side, we'll directly get it to be equal to sigma square by 2 epsilon naught. This, my friends, is the pressure, excess pressure is the reduce in pressure due to electrostats, due to charge present. So electrostatic pressure is nothing but the reduction in pressure due to charge. And this delta pressure will be equal to minus sigma square by 2 epsilon naught, or you can also say it is reducing. Clear? This is one important thing. Okay, now application of electrostatic pressure. Let's see, there's a question like this: equilibrium of liquid charges in a soap bubble. In a soap bubble, there will be different kinds of forces. If you observe, there are two surfaces. Okay, in equilibrium condition, there will be pressure P naught from outside. There will be pressure inside, which is Pi. There will be excess pressure inside, which is equal to 4T by R. Right. So we'll write the whole thing. These are all the forces. Pressure, surface tension pressure will be equal to 4T by R. And the air pressure from the outside will be equal to P naught into 4 pi R square. P naught basically. Air pressure out due to outside. And the electrostatic pressure is now how much? Sigma square by 2 epsilon naught. It is minus inside. And pressure due to bubble from outside, inside will be some P. Pressure inside. So from these all you can say pressure inside will be equal to P naught minus sigma square by 2 epsilon naught plus 4T by R. This is another way of solving it. Getting it, guys? So till now in normal surface tension problem we use P naught plus 4T by R. Now inside pressure will be equal to P naught plus 4T by R minus the electrostatic pressure. Clear? So this is how we solve it. And equilibrium for liquid charges, this is how it generally works. And suppose this is a given question condition saying P inside is equal to P outside. Then what can we say, which implies that 4T by R will be equal to sigma square by 2 epsilon naught. You can solve all these problems based on this particular simple topic. Is it clear? Pressure inside, till now we discussed, is equal to P naught plus 4T by R. But now we have to subtract additional pressure due to electrostat. So also you can say pressure excess inside a bubble will be equal to 4T by R minus sigma square by. So these are multiple ways of looking into it, guys. Understood? Same thing, no confusion, right? Once we understand electrostatic pressure, it is just like surface tension pressure. Everything is the same. Okay. This is another wonderful question. A brass has a tensile strength of 3.5 into 10 to the power 8 Newton per meter square. What charge density on this material will be enough to break it by electrostatic force of repulsion? How many excess electrons per square area A will be there? What is the value of intensity just outside the surface? Okay. This is a very Very simple question. For a small dx element, you have to solve the entire thing. Okay. Brass has this tension. What charge density on this material will be enough to break it by electrostatic force? Which means you take a small element like this, small element, and there's an external the force will be repulsive because of charge density, and then this has a tensile strength. Tensile strength is the maximum stress it can undergo, because of which it will beyond which it will break. So simple. Here also we'll use the concept of this pressure. We know due to brass body will behave like a charge will always come to the outside, right? Any brass body also, the charge will come to the outside. You just take a body like this, charge will always come to the outside. So we can say excess pressure sigma square by 2 epsilon will be equal to the tensile strength. At this condition, we will get the it will break down. So what you will just substitute the value, sigma square by 2 epsilon naught is equal to 3.5 into 10 to the power 8. Just substitute the whole value, sigma square is equal to 3.5 into 10 to the power 8 into 2 epsilon naught. Okay, but sigma is under root of this whole thing. 3.5 into 10 power 8 into 2 epsilon naught. What is the value of epsilon naught we know? It is 8.85 into 10 to the power minus 12, right? Substitute the value here. Substituting this here, we'll get root of 3.5 into 10 power 8 into 8.85 into 10 to the power minus 12. Hogi baat. This is approximately equal to root 31 into 10 to the power minus 4. This is coming out to close to 5.57 into 10 to the power minus 2 Newton coulombs per meter square. This is the charge density, guys. We got the answer. Now what is the field? What will be the value of intensity just outside the surface? Intensity just outside the surface is sigma by 2 epsilon naught, which is also written as tensile strength by sigma. We can use this method also, we'll get the answer, right? So we'll get the answer to be how much? Tensile strength is 3.5 into 10 to the power 8 by 2 epsilon by tensile strength by sigma, which is 5.57 into 10 to the power minus 2. Using both of them, we are getting answer close to 35 by 6. It's approximately 6.2 into 10 to the power 9 volt per meter. Getting it, guys? It's a very simple question. Clear? Yes. Now for the next question, it's a single option correct answer. So this is also another trick, this is a very good question basically. That's why I put this in. So this is a very good question I want you guys to solve. Now these are all equipotential surfaces. We didn't have a problem on equipotential today. That is why I made a question on equipotential surface. Now some equipotential surfaces are shown in the figure here. 3.72 is not the question number. Okay. The magnitude and direction of the electric field is. So if you observe, we know one thing, the field is perpendicular to equipotential surfaces, right? It is perpendicular to equipotential surfaces. And we also know field travels from higher potential to lower potential. The direction of field is from higher potential to lower potential. So in the given question, what is the direction of field? You can just imagine directly like this. No, this will be the direction of field. Getting it? The direction of field will be in this particular direction. Because this is higher potential, this is lower potential. Very simple. No doubt. So this angle is given as 30 degrees. And this length is per centimeter. Each one is 1 centimeter. So how much will this length be? Let's call this x. We can say x will be equal to 1 sine 30, which is equal to 0.5 centimeters. Which is 5 into 10 to the power minus 3 meters. And the potential difference is 10 volts. Getting it? The potential difference between these 2 points, actually this is 10 centimeters. Sorry, my bad guys. This is 10 centimeters. So we are getting the answer to be 5 centimeters here. The potential difference is 10 volts and the separation is 5 into 10 power minus 2. So what is the field value? Field into 5 centimeters is only equal to 10 volts. No? So directly we will get field to be equal to 10 by 5 into 10 to the power minus 2. This is coming out to be 200 volt per meter. And the angle with the x-axis is how much? This is the direction of field, so the entire angle will be 30 plus 90, which is equal to 120 degrees. By seeing only you can say it is 200 volt per meter square, making an angle 120 degrees with the x-axis. This is one of those IIT questions. So yes, good one Sim 24. So this is another question. Okay, now for the next one. This question came in JEE 1990. So this is why I put this. We need to have an IIT question. How can we have a question session without an IIT question? Because we are cracking IIT. So this is the question, guys. Three concentric spherical metal shells A, B, C of radius A, B, and C have radius charge density sigma, minus sigma, and sigma, respectively. VA, VB, VC are potentials of the cells A, B, and C, respectively. So we have to match this. This is a column matrix matching question. So this how it works. We have three charges. One is sigma. So the total charge will be sigma into 4 pi r square. All right. The total charge will be sigma into 4 pi r square. So this will be sigma into a square into some constant. This will be sigma into b square minus this is sigma into c square. No, this is c square. No, okay. C, b, and a square. The charge here is minus. The charge in the middle sphere is minus sigma into b square. The upper one is sigma into c square, and the inner one is sigma into a square. Into 4 pi, of course. Into 4 pi everywhere. Okay. Now the potential. When you're taking potential, it is k q by r square. K, they're automatically 1 by 4 pi will get, right? We'll get potential will be q by 4 pi epsilon naught r. So directly what I'll do is this 4 pi will get cancelled to this 4 pi. So I will not use this 4 pi now. I will in fact write off q by 4 pi here. Q by 4 pi is coming out. This is a simpler way of making calculations easy. Understood? I am directly writing q by 4 pi into by epsilon naught r. Q by 4 pi values I am writing everywhere. Understood? This way I will not do any calculation mistake. Now potential at A. So remember one thing, potential at A, it is inside the whole thing, right? Inside the whole shell, two shells. So by logic you can also say inside, if it's inside the whole, inside the entire, all the shells, the potential at A will be equal to potential of shell C plus potential of shell B plus potential of shell A. All the three of them individually you find out, you will get the answer. Potential of shell C will be how much? K q by R. So K directly q by 4 pi we wrote off. Sigma C square by epsilon naught into C plus sigma B square by epsilon naught into B plus sigma A square minus here by epsilon naught into A. So this is how we'll get it. So you simplify the whole thing, you're getting the answer to be sigma by epsilon naught into C minus B plus A. Getting it? Why I'm explaining this again now? Listen carefully. So once it reaches, so your every potential question you are thinking from infinity to the particular point, right? So if you are coming to the particular point A, you are coming from infinity to the point C. Once you enter C, once you enter inside the shell C, the potential due to the shell C will remain constant. What is the value equal to? Sigma C by epsilon naught C square, which is equal to sigma by epsilon naught C. Got it? This is sigma C square by epsilon naught C, which is coming out to be sigma C by epsilon naught. So from infinity, if it comes to the particular shell, the value will become fixed. Once you go inside, the potential due to this shell will always remain sigma C by epsilon naught. क्योंकि अंदर आते ही field 0 है. When field is 0, the potential will remain constant, which is equal to potential on the surface, which is exactly this one. Similarly, once you go inside the shell B, the potential will again become minus sigma B by epsilon naught, just like the above incidence. And once you get inside field A, it will be sigma A by epsilon naught due to this shell. So entirety, if you see, it will be sigma C by epsilon naught minus sigma B by epsilon naught plus sigma A by epsilon naught. Getting it? So the answer for A is 3. Got it? And for C, You can simply say the potential will be due to every charge. You're coming from outside. When you're coming from outside, every spherical charge will look like a point charge. So you can directly say it will be equal to Q total by epsilon naught into R. Getting it? What is the Q total now? Q total, you can find out Q total by saying Q total will be equal to 4 pi common lele sigma into A square minus sigma into B square plus sigma into C square. This whole thing by C. By 4 pi epsilon naught C. 4 pi getting cancelled. Clear. So you will end up getting sigma common sigma by epsilon naught into A square minus B square plus C square by C, which is option 1. So we got off the answer. For A option is 1 and for C for A option is 3 and for C option is 1, which means for B option will be 2. Clear? Yes, very good, very good. Anjali, good answer, very good job. So this is clear, right, every one of you? So now for the next question. If shells A and C have same potential, the relation between A, B and C radius, between the radii A, B and C. If shells A and C are at same potential, then the relation between A, B and C. Okay. We already found out these both potential for A and C. We can directly equate both of them. So what do we get? Sigma by epsilon naught C into A square minus B square plus C square will be equal to sigma by epsilon naught into A minus B plus C. Just substitute the whole thing. Sigma by epsilon is cancelled on the other side. C to the other side. A square minus B square plus C square is equal to AC minus BC plus C square. C square is getting cancelled. So what do we get here? A square minus AC is equal to B square minus BC. A square minus B square is equal to, or we'll just write the ulta way. B square minus A square is equal to B minus A into C. Yes, very good. That is the correct answer. Great job. This is B plus A into B minus A. Simple. B minus A into C, which implies C is equal to B plus A. This is a question from IIT. So great job, guys. Very good answer. It's simple, right? IIT-JEE questions are not complex. It's just about understanding how to write correct equations. Very important point. I'm telling you guys again. Learn how to write equations rather than remembering formulas. Write equations. Field equation. What is field equation? Delta V is equal to minus E dot dr. This is a field equation. This is not a formula. Okay. So this way you can solve. Okay. Formula is when you remember E2 minus E1 is equal to V2 minus V1 into E2 minus E1 is equal to V2 minus V1 by R, something like this. These kind of things are formulas. You remember the basic concept, which is only the equation, and from there you will solve everything. In fact, you know this. This is the main basic equation. U is equal to minus F dot dr. By Q you do, you'll get off the answer. V is equal to minus E dot dr. This is the method. So this is about it, guys. So that is the end of session for today. It has been a great session. The participation has been great. Yes, you Divya also. Divya, no? What is the name? I forgot. Divya or Vidya? Great answering in the end. I want you also to come regularly. Yes, we have a quiz today. Topic is general. I decided there is too much tough. Like the way everyone is answering, I thought I have to give a general quiz only. Then there will be some discrepancy. So do stay tuned. All of you guys come at 10:30 to the daily quiz show. We have the eighth episode today. The daily quiz show's 8th episode. Episode 8. We'll have general quiz at 10:30 for 1.5 hours. Do stay tuned in. Those late nighters who do not sleep late, who do not sleep until late night, do come to this quiz. Ramesh, and those of you who watch Big Boss or any such things also, just watch it and come to the quiz so you can just see the questions and analyze accordingly. Understood? So make sure you come there, and don't forget, when you're taking the subscription, use this code NSS1. Use the code NSS1. and hit the like button. Don't forget to hit the like, subscribe, share this video everywhere. Okay, hit the like button, hit the bell icon, subscribe it everywhere. And from next class, mostly from tomorrow, we will start having classes at 5 p.m. in the evening. All right, we'll have a change because we are starting a new topic now, which is capacitors. I'm going to start it a little more early from tomorrow, guys, because that is the best way to compress the entire topic into one particular time. Okay. So from tomorrow we'll be having classes at 5 p.m. on this channel. Come at 5 p.m. tomorrow. This is just after the school gets over, so that you also can come in and sit relaxed and listen to the class and understand wonderful visualization which I'm going to give you. All right. So until next time, crack JEE in English. Until next time, adios amigos.